The same storm system is doing two things at once, and the scale of it is almost impossible to comprehend. Tornadoes carving through the southeast, walls of snow burying the upper Midwest under more than 4 feet of ice. Tens of millions of Americans caught between fire and freeze, and the system driving all of it is still moving. This is not a forecast. This already happened, and the numbers coming in are staggering. Approximately 36 confirmed tornadoes, over 500,000 homes and businesses without power, more than 17,000 flights disrupted across the United States. Up to 52 inches of snow in parts of Michigan, a storm so wide, so violent, and so meteorologically complex that it forced governors to call in the National Guard while simultaneously warning coastal communities to brace for something entirely different. But here is what makes this event unlike almost anything on record. It is not one disaster. It is two disasters running in parallel, both fueled by the same single storm. And understanding how that is even possible changes the way you think about what American weather has become. The system has a name in meteorological circles. It is called a bomb cyclone. That term is not dramatic license. It is a precise classification. A bomb cyclone forms when atmospheric pressure drops by at least 24 millibars in 24 hours. This one deepened to 944 hectopascals by the time it moved through Quebec and into the Labrador Sea, a measurement that reflects the extraordinary intensity this system ultimately achieved. It entered from the Pacific Northwest on March 13, 2026. By the time it crossed the central United States and churned off the eastern seaboard, it had left a damage corridor stretching from Texas to Michigan to the Carolinas. But that is only part of the story. What made this storm so operationally complicated and so dangerous for emergency managers was its architecture. A bomb cyclone of this scale does not produce a single type of weather. It produces a battlefield. The southern edge of the system pulls warm, unstable Gulf air northward, creating the exact conditions tornadoes require. Surface temperatures above 50 degrees Fahrenheit, steep lapse rates, and powerful wind shear. Meanwhile, the northern edge of that same system drags Arctic air down from Canada, compressing it against the warm sector and generating the precise conditions for historic snowfall and blizzard-force winds. These two worlds were not touching each other. They were separated by hundreds of miles of geography and dozens of degrees of temperature, but they were both being driven by the same low-pressure engine, the same rotating atmospheric system spinning across the heartland like a top. On the southern edge, the National Weather Service Storm Prediction Center placed tens of millions of Americans under tornado watches across a swath running from the Florida Panhandle through Louisiana, Arkansas, Tennessee, Illinois, Missouri, Virginia, the Carolinas, Maryland, Pennsylvania, and New Jersey, officially told to be ready to take shelter immediately. The tornadoes that followed were confirmed at approximately 36. Their maximum rating was EF1 on the enhanced Fujita scale, which means winds between 86 and 110 miles per hour. An EF1 tornado does not sound catastrophic in isolation, but dozens of them moving across populated corridors is a different kind of threat entirely. Near Walnut Corner, Arkansas, one tornado destroyed grain bins, downed trees, and demolished a camper. In central Illinois, 6 tornadoes touched down in rapid succession, ranging from EF0 to EF1 with winds reaching 90 miles per hour. In southeast Missouri, 3 separate tornadoes were confirmed by the National Weather Service office in Paducah, Kentucky, following an outbreak centered on March 15th. The storms were moving fast. Reports from Fox Weather noted that individual cells were tracking northeast at 60 miles per hour, fast enough to outpace many standard emergency alerts, fast enough to cross county lines before warning sirens could complete their cycle. And in East Texas, something else was falling from the sky. Tennis ball-sized hail. Structures absorb that kind of impact differently than human bodies do. The damage to rooftops, vehicles, and agricultural infrastructure from hail events in a single outbreak can run into the hundreds of millions of dollars before a single tornado touches ground. Yet what comes next in this story could be even harder to absorb. Simultaneously, while tornadoes were raking the south, a different emergency was unfolding 1,000 miles to the north, in a landscape that looked nothing like the same event. Minnesota, Wisconsin, Michigan, the upper Great Lakes, the high plains, Millions of Americans under blizzard warnings, millions more under winter weather alerts, wind gusts reaching 69 miles per hour near Grand Marais, Michigan, among the highest recorded inland gusts of the event. In Minnesota, accumulations passed 25 inches before the storm had finished. In parts of Michigan near Round Lake, the total snowfall reached 52 inches. That is more than 4 feet of snow in a single event, in a region that is no stranger to winter weather. The Minnesota National Guard was activated. Governor Tim Walz authorized emergency operations. In Maryland, Governor Wes Moore declared a state of preparedness. In North Carolina, Governor Josh Stein issued emergency guidance and urged residents to activate weather alerts on their phones immediately. These were not precautionary statements made for political optics. They were official governmental responses to an active, evolving, multi-hazard emergency. Power outages struck Michigan harder than anywhere else, with over 130,000 customers losing power at points during the storm. Florida and North Carolina followed closely. Trees came down in Bloomington, Indiana, under winds gusting between 60 and 75 miles per hour. Across the broader impacted zone, more than 500,000 customers lost power at the peak of the event. In winter conditions, that is not an inconvenience. It is a survival emergency. Schools closed in Raleigh and Chapel Hill in North Carolina. Districts across Wisconsin and Minnesota suspended operations entirely. Chicago's O'Hare International Airport and LaGuardia in New York became choke points for the nation's aviation network. By Monday evening, more than 4,700 flights had been canceled. By the time final disruption counts were tallied, 17,700 American flights had been affected by this single storm complex. Passengers stranded in terminals across the Midwest and East Coast were experiencing the downstream consequence of a weather system that was, at that same moment, also spinning up tornadoes 5 states to the south. The two emergencies felt like separate news stories. They were, in fact, the same one. And now, scientists fear history may be repeating itself, or more precisely, may be accelerating toward a new kind of normal. To understand what this event represents in context, it helps to look at what has come before. March tornado outbreaks are not unprecedented in the United States. The belt of terrain stretching across Arkansas, Tennessee, and Mississippi, sometimes called Dixie Alley, experiences significant tornado activity every spring. The last major March outbreak before this one struck Arkansas and Ohio in March of 2024. The meteorological fingerprints were similar. Gulf moisture surging northward, colliding with cold air in the upper levels, generating explosive storm development. But what distinguishes the March 2026 event is not the tornadoes alone. It is not the blizzard alone. It is the simultaneous continental-scale expression of both, within a single pressure system that was strong enough and wide enough to sustain radically different weather regimes on its opposing edges. No historical tornado-blizzard combination event matching this scale and structure has been documented in the official record. That matters. It means meteorologists and emergency managers had no direct precedent to draw from when modeling response protocols. The training exercises, the resource deployment models, the public communication systems, all of them were built around single hazard events or sequential disasters, not simultaneous ones with diametrically opposite temperature requirements. Tornadoes require warm, unstable air, surface temperatures above 50 degrees Fahrenheit, high humidity, wind shear. They are thermodynamically incompatible with blizzard conditions. A blizzard demands surface temperatures at or below freezing, Arctic air masses, and sustained winds above 35 miles per hour carrying significant snowfall. You cannot have a tornado become a blizzard. The physics do not permit it. What you can have, and what this event demonstrated, is a storm system large enough to straddle both worlds at once. To hold tornadoes in its southern periphery and blizzards in its northern periphery, separated not by time, but by latitude, and to sustain both simultaneously for days. The GOES-19 satellite operated by NOAA tracked the system's progression in real time. The imagery showed a classic comma-shaped extratropical cyclone, its cloud head draped across the Great Lakes while its tail curved southward across the Gulf states. The scale of the cloud field alone was enough to span the distance from the Canadian border to the Gulf of Mexico. The National Weather Service offices across the country, from Paducah, Kentucky to Duluth, Minnesota, issued their separate simultaneous warnings. Each office described a genuine emergency. Neither had the full picture of what was happening across the system as a whole because no single forecast office covers the entire country. The scale of this storm exceeded the jurisdictional reach of any one meteorological team, because what happened next could rewrite how emergency management in the United States is structured. By March 17th, the bulk of the storm system had churned off the East Coast and into the Atlantic, but it left behind a country still accounting for its damage. Power restoration crews were working in ice-covered neighborhoods in Michigan, while tornado damage assessment teams were simultaneously documenting debris fields in Arkansas. In the north, roads remained impassable under 4 feet of snow. In the south, insurance adjusters were beginning the first surveys of rooftops stripped by hail and wind. No federal FEMA disaster declarations had been issued as of March 19th at 1400 hours Coordinated Universal Time. That gap matters, not because it signals government indifference, but because it reflects how disaster declarations work. They lag behind events by 48 hours or more. The absence of a declaration on the 19th was not evidence that this was a minor event. It was evidence that the administrative machinery of disaster response operates on a different timeline than the storm itself. The American Red Cross was on standby in northern communities for standard winter emergency operations. State National Guard units in Minnesota had been activated for emergency response. No federal military assets beyond state-level National Guard were mobilized. The event was large, but the confirmed fatality count, at least 3 deaths tied to the winter weather side of the system as of the most recent reporting at the time of this account, meant the response remained calibrated rather than crisis level. That detail, a death toll that, for a storm of this scale, remained remarkably low, should not minimize what occurred. It should provoke a different question. Approximately 36 tornadoes, 52 inches of snow, over 500,000 power outages, 17,000 flight disruptions, tens of millions of people under tornado watches, and the loss of life was far smaller than the raw numbers might suggest. That is not luck alone. That is the National Weather Service issuing accurate, timely, and widely received warnings. That is school closures happening before conditions deteriorated. That is National Guard prepositioning before the worst snowfall arrived. That is decades of investment in public alert infrastructure, the emergency notification systems, the weather radio networks, the smartphone alerts, doing exactly what they were designed to do. But those systems were built for the hazards of the past. And what is emerging now raises a harder question. The climate research community has been documenting a pattern sometimes called weather whiplash, the increasing frequency and intensity of rapid transitions between extreme weather states. The same atmospheric dynamics that drive bomb cyclone development are sensitive to the temperature gradients between the Arctic and the tropics. As those gradients shift, as the Arctic warms faster than the mid-latitudes, the jet stream becomes more erratic, more prone to deep meandering, more capable of dragging cold air far southward while simultaneously pulling tropical moisture far northward. What that means in practice is not that every storm will be worse. It is that the most extreme end of the distribution, the events that produce both tornadoes and blizzards within a single system, the storms that cover 12 states simultaneously, the pressure systems that achieve 944 hectopascals as they rage off the continent, may become less rare. There is still much that is genuinely unknown. The final damage cost of this event had not been formally tallied as of March 19th. Early estimates placed it below $10 million, but that figure reflected only the data available at 1400 hours. UTC on that date, before full infrastructure assessments were complete, before agricultural losses were compiled, before the full scope of the aviation disruption was priced, historical bomb cyclone events of comparable size have frequently produced billion-dollar damage totals once final accounting is complete. The blizzard warnings in the northern plains were still active. 6 to 12 additional inches of snowfall were forecast for some areas through March 20th, accompanied by winds of 40 to 50 miles per hour. The tornado risk in the southern plains, while diminished, carried a 5% probability of isolated activity as of midday March 19th before clearing by evening. The storm was not entirely finished, and the conversation about what it means for emergency preparedness, for infrastructure resilience, for the design of warning systems capable of handling simultaneous, multi-hazard events across continental distances had barely begun. Meteorologists confirmed approximately 36 tornadoes and left open the question of how many more had touched down in areas where radar coverage is thin or ground truth surveys had not yet reached. Snow totals of 52 inches were measured where instruments existed. In the rural corridors between observation points, no one yet knows what fell. The satellite keeps watching, the pressure charts keep updating, and somewhere in the data, in the wind shear profiles, in the moisture flux measurements, in the Arctic air mass trajectories building for the following week, the next system is already forming, already being tracked, already moving toward a country that is still digging out from this one. The question is not whether events like this will happen again. The question is whether the systems built to protect people were designed for the world that is already here.